So hey everyone, I think we probably should be starting. I was hoping there'll be more of you, but let's start with a few announcements. I'm Ymir Vikusson, I'll be your session chair. We're going to have Birds of Feather and workshops after this session, so please check them out. There's also going to be demos in the demo room. It's behind the registration desk, and that's starting at 6. And there's also, if you need anything to print, there's a printer booth next to the Tarina booth in the main hall. So if you need to print a boarding pass or something, that'd be a good place to go. Good. So this is the Green and Clean session, where we're going to be asking questions about this new buzzword that is popping up everywhere. And it's becoming increasingly relevant because, I mean, if you think about just the world's IT infrastructure, it's using up more energy than Russia. And if you just look at the spam messages that we're receiving every day, it's using up the same, or it's releasing just as much greenhouse gases as 1.6 million cars. So we can think about these big numbers and we need to put them in context. And with that, I'll introduce the first speaker. He's Robert Pekal, has a master's degree in electronic and telecommunication science from Poznan University of Technology. And he's been working for the Polish NREN for 14 years. And without further ado, he's going to talk about his first talk here. Let's just start that. Go ahead, Robert Pekal.
Good afternoon, ladies and gentlemen. My name is Robert Pekal, and I will present you a green network giant presentation. Need to switch this presentation, run. Okay. Climate change is a challenge for the whole world. It affects all countries and all people in each country. Governments represent a country population, but they do not regulate and control our every action. So while governments may agree on the gravity of the challenge and on common objectives to meet the challenge, it falls to all of us as individuals, families, companies, and public bodies to fulfill those objectives. So energy consumption of the internet, as you can see on the slide, it's growing rapidly in recent times, mainly due to increasing numbers of devices connected to networks and explosion of traffic volume fueled by new media and mobile application, both causing a continuous process of extension of existing networks and development of new networks. This claims that ICT sector is responsible for more than 2% of global carbon emission, which is similar number to aerospace industry. It's worth to mention that energy prices are going to be higher and higher, so even at this moment energy expenses are near 25% of TCO costs of networks. If talking about OPEX, it's even more so. Organization trying to find savings in the operational field of their activity, besides the regular hardware renewal cycle, look to reduce power consumption as a significant part of their cost. This includes power consumed by network infrastructure, servers and storage, as well as cooling systems and auxiliary devices. Many organizations have quickly become receptive to green IT because of its potential for energy savings. This fits well with the pressure coming from society for every organization to care about the issues of sustainability and social responsibility. So turning to green technologies, it's worth mentioning as being beneficial for the environment. So what we need to act as a first, we need to measure some numbers, then act to reduce consumption and emissions. GIANT is a project involving the national research and education networks in 30 European countries and takes mentioned changes as a priority. As a part of ICT sector, NRENs contribute significant levels of greenhouse gases to the atmosphere, and this is part of the global problem. The Green Giant team decided that we, at the first step, will be measured the current level of GHG emission by NRENs. So we adopted the ISO 14046 standard in order that results could be compared with each other and over the time. The partners also decided that as far as possible they would get directly involved in the measuring process in order to learn about the contribution of their networks to global warming and how to reduce that effect. And it was agreed also that the measurements of overall GHG emissions and absorptions would be independently validated. To do this, we as Green Team developed an accounting tool to help with the GHG audits. This tool was developed by Unici. It's a partner in our team. This tool categorized the network into meaningful components and enabled the audits to be carried out in the systematic way. It also made clear that various steps in calculating the carbon footprint of various diverse components, such as core routing equipment, data center cooling, and staff transportation. On this slide, wow. There is something wrong because it's not skipping. Yes, on this slide, you can see the baseline audits which were carried out and independently, as I mentioned, validated by the ForceNet company for our national networks of the Green Team partners. It was Hungary, Nordunet, Pioneer, Surfnet, GNet, and HiaNet, as well as Giant itself. This audit was also published as the first deliverable of our team, named Study of Environmental Impact. And this document is available on Giant website. The partners are now using the results achieved of the baseline audits to put in place measures that will reduce carbon emissions while maintaining service levels and saving money. Having such calculation, we've tried to propose some action that will help to reduce GHG emissions. And one of the examples is distance working. What's distance working? Or teleworking. It's a paid work that's done outside the actual workspace. And it seems that this type of work it's more and more common as ICT is developed and possibilities for its use, including at home, are increasing. One of the main advantages of such type of work is that commuting is avoided, but saving a significant amount of GHG emission, but there is also a bad side of this regarding some social connectivity. In the Smart 2020 report, it's claimed that currently, the largest opportunity identified within the materialization is teleworking, where people work from home rather than commute into an office. The report estimates this saving to account for 0.26 gigaton out of the total anticipated business as usual emission of more than 51 gigaton CO2 in year 2020, or speaking in relatives, about half of the percent. On this slide, you can see the part of the Smart 2020 report. It's enabling the low carbon economy in the information age. It shows how ICT can be used to reduce emission in all walks of life. Such reductions could, they say, amount to 5 times the carbon footprint of the ICT sector itself. In in speaking in other words, the industry can more than offset its own emission by helping to reduce emission elsewhere. This is called the enabling or mitigating effect of ICT. And this consists of dematerialization, smart logistics, smart buildings, and smart grids. As an impact of dematerialization, it's claimed that total 0.46 gigaton can be saved in 2020, and the dematerialization is a process by which an ICT product or service can replace a high carbon activity with a low carbon one. As an example, a good example of this is videoconferencing, when we exchange travels with some virtual meetings. In Denmark, the UNICE partner implemented a policy of teleworking. One of the main advantages of this is that commuting is avoided and thereby saving a significant amount of GHG emissions, especially if person cars are used for the transportation. Furthermore, many employees see distance working as potentially allowing more flexible and integrated planning of work and leisure time. However, a drawback mentioned by many is that the social contact with colleagues diminishes as a result of days working away from the organization workplace. And this slide shows, you can see on the slide assumptions and study results. A case study of 30 people at UNICE showed that the distance working saved near 320 kilograms of CO2 emissions, which is corresponding to 3 tons when we scale this to full year, which is a 1% reduction. And it means, I told in previous slide, it means that it's 2 times better than the projection of the Smart 2020 report. These results also are published on GEANT website as Team's second deliverable. So details are in this deliverable. And it's worth to mention in the last bullet that an extra gain of this study was to raise awareness of UNICE employees. The next dematerialization example is videoconferencing. We know this tool. It's a kind vital tool for the research community and NRENs. We are using this for many years as a service layer on our network infrastructure. Of course, there are some opponents and supporters in the industry, in the total industry of this service. Some pros you can see on the slides. We are saving traveling money, working hours, GHG emissions, some efforts, but there is also some cons raised by opponents that we are losing face-to-face contact with our partners, and this is losing also a part of information. We are losing also our own experiences and discovering, and we are losing social events and contacts as well. Yeah. A study was made by our Hungarian partner, and this slide shows the description of the service considered in the study. It's IP-based VC service countrywide, and using more than 150 VC rooms in Hungary. and it's rich with service portfolio. It's MCU based with gatekeepers, recording, archiving, and streaming. It's also possible to connect via as a VoIP and PSTN clients. An accounting tool was developed to calculate savings. Using video conference services versus hypothetical face-to-face meetings. Each user of Hungarian network can follow their own GHG emission and savings of using VC equipment. It's worth to remember that precise calculations are nearly impossible due to very little public information available about production, transportation, and disposal of VC equipment. It means we don't know how much GHG emission is involved in the life cycle of the product itself. The results also do not take account of the operational impact of video conferencing on the environment. To run video conference, we involved MCU, VC equipment at each endpoint, but also network infrastructure to connect all the elements. All of this consume electrical power and also require cooling, which entails an additional level of power consumption. But NIF accounting tool is able to collect some data as shown on this slide. It's log files about the VC sessions, information about location of codecs, route information, and time required to travel to have some hypothetical face-to-face meeting. All this data are put into the algorithm which processes log files from gatekeeper, resolves location based on several information, calculate distances. Then the algorithm is computing hypothetical traveling time with GHG emissions and as a deduction only considering some estimation of electricity consumption of VC equipment. The results are generated and displayed and are, as I mentioned before, available for every user. This data is mainly raising awareness of NIF users about GHG emission, and it's very helpful to improve users' current pattern. The next topic we were involved as a team, it's management systems. According to an ISO, having an environmental policy and establish GHG account may not be sufficient to provide an organization with the assurance that its performance not only meets but will continue to meet its legal and policy requirements. To be effective, they need to be conducted within a structured management system that is integrated within the organization. PSNC has made real advances in developing a green network management system. Using this optimization in energy efficiency can be achieved by giving preference to efficient service, optimizing or replacing software, eliminating underutilized network devices, and reacting to some abnormal energy usage, which can happen in our networks. Major benefits can be achieved by monitoring energy usage and taking action promptly. The result of our work is also published in second deliverable, and it's available on Giant website. PSNC study on green management system discovered that tremendous reduction in power consumption can be achieved by a few simple steps shown on this slide. The following bullets describe an operational approach, starting with straightforward initiatives and ending with more complex one. All the steps described are very simple when considered individually, and each of the steps will lead to reduction in overall energy consumption, because nowadays most of the individual hardware elements provide us with some kind of energy saving mechanism. Likewise, application can be optimized or replaced as well, but it must be acknowledged that all of the elements presented here are interconnected and influence each other in the delivery of service to the end user. Trying to manage energy consumption on the service level can lead even to more energy savings, but it's a complex holistic approach. Typical scenario of such approach might look as follow. If the number of active session drops below a certain threshold, move one of the virtual machine from server X to server Y, as this will produce more energy efficient load distribution. And it is even more complex when we require that it should be done automatically without any user action. As can be seen on this slide, in order to execute even such simple scenario, complex interaction between hardware, software, and the network elements is required. Such interaction can be seen as a decision-making process based on the current state of the hardware and software elements used to provide the service. However, to make a decision, we need involve multiple sensor to monitor each element of the service. An example is a server load, traffic, or temperature. And based on the input we have from the sensor, historical data, and some rules, special agents can decide what action should be taken. Once the decision is made, a number of effectors are required to implement configuration changes in network. An example of this is, for example, move a virtual machine image or shut down some cluster hosts. We found that NMS is the ideal vehicle for implementing service power management, where human involvement is reduced to a minimum. Such extension was made by locally based Verax company, which is collaborating with us and run on our network. This extension consists of some rules-based engine which communicate with NMS core internals. With this extension, we are able to monitor and control the energy consumption of individual devices and allow custom-defined energy management policies. And we think that this implementation is quite innovative, and we achieved that the next generation product designed to enforce energy consumption control and implement cost-effective energy policies. The road, of course, taken by us, it's innovative, but it's not necessarily unique. We can find similar strategies in other organizations as well. But our case shown how real benefits can accrue to NRENs by using a green network management system. And to end my presentation, I want to define some future lines of action we want to take as a team. It consists of the bullets shown on this slide, and it's to recruit more NRENs into environmental policy. We want to collect and disseminate some best practices documents. We want to set targets for efficiency and for use of carbon offsets based on the data available on the reports published on Giant website. We want to also develop NREN insights and practice on green IT, so other also may benefit from these documents, and to push NRENs to improve their energy efficiency in networking and computational infrastructures. And this was the last slide. Thank you for your attention. If there is any question.
Let's take the speaker first. Questions from the audience?
Roland Knights from SurfNet. In one of your earlier slides, you said that the power consumption is 25% of the TCO. Which lifetime of the system are you assuming?
We are talking about this first slide. I believe that the energy expenses constitutes. It was that bullet, yeah?
Yeah,
we
it's
are
at
25%.
Right.
Yeah, we consider different equipment, get an average from that, and it seems that it's the cost of the power in expected lifetime. It's near 25%.
And you know what the lifetime is, or on a 10 years, 15 years, or?
You know, we think it's 5 to 10 years. It depends on the type of equipment. 5 years, for example, for servers and data center equipment. 10 years for some teletransmission equipment.
Okay, thanks.
Hello. Hi, my name is Erikur. I'm from Green Cloud. So based on your research, how much energy would you consider could be saved by turning off the equipment in a fully loaded data center?
You know, it's also depends on some software, because of course you can turn off some hosts on data center, but also we found in our research that software itself consumes different amount of energy doing the same thing. You know, it's an efficiency of the code of the software, yeah? But it depends on configuration and on type of application you are using, and the critical time you need to discover the service, for example.
We have time for a couple more questions.
Yes, not really a question, but a comment. A very great part of the electric consumption come from the facilities like coolers, UPC, and so on. You don't speak about that. It can be in half the quantity for the IT.
You know, it's described. You can find this on our deliverable as well, because it's described the ratio about all infrastructure to computers and servers in data center. It's called a PUE factor. So you can find all calculation and examples in our deliverable, and it runs. It seems it runs from near 2 to 1.1, 1.2.
It depends.
Yeah, it depends.
Essentially of the cooling.
Yeah, it depends. You know, essentially about some cooling efficiency and the way you try to cool your equipment. And this is quite a good example. UNIC it's a leader in this, and it's very well described. I don't have enough time to put some slides about this, but if you are interested, we can speak on the break, or you can find this on the Géant website.
Yes, and Iceland is a nice place to do that.
Yeah, I know. It's a natural place to do that.
Good. Any more questions? No more questions. So I have a question. Was there any pushback when you made these changes? Maybe I should do that on the mic. My question is just, was there any pushback when he was trying to propose these changes? I mean, there's kind of the greenness and like all the savings that you can make versus the reaction from the people running the systems, reaction from the users, and so forth.
You know, everyone it's aware about the energy he consumes, because every of us need to pay bills for the energy. So it's a natural a mechanism to look into some green technologies, yeah, because they in effect by the end of the day they help to reduce your bills.
Very good. Okay, any final questions? Nope. Let's thank the speaker again. Next up is Albert Henkel from SurfNet. He's going to be talking to us about how to build an ICT community and how you can save money. So let's, that's not the right one. Let's get the right one here. Where did this go? Building a green. Kanskje like rett. Voilà.
Hello everyone, my name is Albert Henkel, I'm from SurfNet, and as Emir said, I want to talk about how we are building a green ICT community with the higher education people in the Netherlands. But first I want to start on the question, what is green ICT? Many people are asking me this question, and I usually start with, you can split it in two ways. It's the greening of ICT, that's basically the making ICT more efficient, saving money with efficiency actions, such as green data centers, making the cloud green, PC power management, but also looking at the e-waste, making software more sustainable. And the other side is the enabling power of ICT. So using ICT and other processes to make them more green, but also more productive or safer for people to use. And you can see here, for example, the self-driving car in the right bottom corner, or the smart grids, online collaboration, using video conferencing in web lecturing, stuff like that. But if you talk about green ICT and starting a community, then like Robert said, there's this figure of 2%. ICT is using 2% of the total global footprint. And the World Wildlife Foundation says focus on the other 98%, the enabling power. of ICT. But that's a really big scope. That's basically saying we should use ICT in everything, and make everything green with ICT. And ICT is not so much a miracle that it can do this without some nasty side effects, such as the Jevons paradox. When something gets more efficient and more cheap, then people are starting to use it more often. So I'd like to take a more pragmatic view and look at the footprint of a Dutch higher institution. And if you look at the green slice of this figure, then that's the electricity part of the Dutch higher education institution footprint. And ICT is in fact 22% of this, so that's more or less 4 or 5%. If you look at the really big part, it's on mobility, so students, teachers, researchers traveling from home to their work, to the campus, and business travel. So what's interesting, I think, is not only to look at making ICT more efficient, but also take a look at the mobility factor and trying to use ICT to reduce these travels. So why should we want green ICT? I'll go very quickly through these slides because I think Robert has said most of this. If you look at the total global footprint, we all know that we are already using more resources than we can sustain. So it's now at like 1.5 planets, and if we continue like this, as business as usual, then it will raise to up to 2.5 planets. And so we should be more sustainable about our resources, because at some point our resources will be depleted, and then we'll have a bigger problem probably. Here's the 2% again. What I want to point out here is that in the Smart 2020 report, they also say something about the growth of ICT. So even though it's only 2% at this point, it will grow by 6% annually, relatively in the total global ICT global footprint. So ICT will become a more and more bigger factor in the footprint. So it's not only focusing on enabling ICT, but also making if we make ICT more efficient at this point, it will have beneficial effects in the future. Like I said, the enabling power of ICT will help us in getting us to this sustainable level of using the resources of the one planet that we have. So why should we care? Well, first of all, we are part of the footprint of our community, of the higher education institutions. So we have a responsibility to green our infrastructure, our services, because they are part of this of their footprint. But also, sustainability is about collaboration, and what the buzzword at this point is collaboration is the new competition. You see small collaborations, for example, between with neighbors popping up everywhere, and they are procuring their solar panels together, or in other ways working together. And collaboration is what NWENs are good at. We are collaborating with our community, we are collaborating with industry, we are collaborating with ourselves, with other NWENs. So this is something that comes natural to us. Sustainability is also about innovation. Usually innovation is driven by from the economy perspective. You want to optimize your energy efficiency because then you can save more money. But if you ask questions from the other perspectives, from the planet and from the people perspectives, then you get different answers, and these answers can easily be more transformative to the environment and eventually be better for your profits as well. So sustainability leads to innovation, and innovation is something that NWENs are willing to focus on. So again, sustainability is something that should come natural to us. And if all of this doesn't convince you, then maybe just creating a better world will. So what is the Dutch situation? Our government made agreements with the European Union, and in the Kyoto Protocol to save energy. It's 20% or 30%, depending on what perspective you are taking in 2020. And they just passed on these agreements to the sectors in our country, among which the higher education institutions. And they agreed to be 2% more energy efficient every year from 2005 on, meaning 30% in 2020. So the higher education institutes are more or less mostly focusing on their buildings, making the buildings more energy efficient. But what about ICT? We did an ICT scan on 9 institutions in 2010. And from this scan, we saw that 22% of the electricity bill, like I said, on average is for ICT. 9% for data centers, 13% for PC workplaces. And this figure is rising. And they also looked at what are the areas for improvement. And so the scan was focused on data centers and workplaces. And if you look at the data centers in our community, they usually use too old of equipment. The servers are usually 5, 7 years old before they are replaced. The data center itself is managed in a too cold environment. And the spaces they use for their equipment are way too large for the equipment itself. They don't need all the space they used to in the data centers while they're still using data centers that were built a couple of years ago. And if you look at the workplaces in our community, then especially student computer rooms, the computers are hardly turned off during closing hours, meaning that in the evening and in the weekends and on holidays, they keep running, and in a sense, they don't use power management. And this scan said, well, you can save easily 25% in data centers on the ICT electricity bill and 56% in these computer rooms and on desktops. On average, it's about 44% on the total ICT energy bill of an institution. But even though they see these opportunities, the ICT departments are not working on these solutions because they don't pay the energy bill. They don't really care what the energy consumption is. They want to optimize on procuring the stuff, buying the right hardware, and not optimize on the electricity use because, well, they only have the investment and not the return on the investment. And this is also what you see when we ask this question in our community. Some of them got right to work, very small part. Some of them say, well, it's on my agenda, but it doesn't have any priority. But most of them have no idea what the effects of this ICT scan was. And this basically, to me, reads out that they didn't really do anything about this. So we started, maybe we should build a community and share the knowledge to as large a group as possible. And when we start a special interest group, we have a specific set of requirements which it should adhere to. And it should have a specific team. Well, that's obvious, of course, Green ICT. The special interest group should stimulate community activity. We created a LinkedIn group of which everyone in our community can be a member of and discuss any topic on Green ICT. There should be a place to share knowledge. We have a special site for this. It's called Surf Space. And the community should organize meetings and workshops, and we try to facilitate this through our Surf Academy program. And finally, it should be run by the community, and it should be working for the community. And this is something that is always hard to put in effect, because when we are starting a community, then we have to put some effort in to get this group autonomous. What we also started to do is organize a symposium on Green ICT. First one was in November 2010, and the second in 2012, January this year. Both had over 100 visitors, and after the one in January, we decided we should do this every year, because people really appreciate how we try to sum up the year's work in the special interest group and in the community, and try to share knowledge on Green ICT and sustainability in the Dutch community. We also provide funding for innovative sustainability projects. We call this the innovatieregeling. And the only requirement we give is that these projects somehow reduce CO2 emissions, but how they do this, it doesn't really matter to us, because we want to leave all the solutions as open as possible. We do require that these institutions provide 50% matching to ensure their commitment, and that the results should be shared under a Creative Commons license or an open source license, depending on the content. And here you see a list of projects we had last year, and the 2012 projects just started. And you see that the topics are varying in very different areas, from virtual teaching to raising awareness of the energy consumption of users to really the greening of ICT. After the ICT scan in 2010, we thought maybe we should make this a more continuous approach. And we discussed this with the makers of the model that was used in the ICT scan. And they were working on an online tool, and we decided to make this freely available for our connected institutions during 2012. And we hope to see that they are increasingly they are sharing their solutions for optimizing their data centers and workplaces. And also, it should provide us with a benchmark over the whole community, so that we can see by the end of 2012 where we are with our community. So, I've been working with this community about 1.5 years now, 2 years on the topic of green ICT. So we were wondering what is the effect of the things that we have done up till now. So I put up a questionnaire last week, and I have some draft results from this questionnaire I want to share. First of all, I started with, are you familiar with this community? And the interesting thing is that most of them, of the participants in this questionnaire, weren't familiar with this, with our community. But they say that roughly half of them work on sustainability. So there's something to gain here for us. But most of them say that the ICT will be important for a sustainable society. In fact, I think extremely important if I see this graph. And they do say, do support our work on sustainability, which is nice to hear, of course. And they say that even we should not only focus on our own services and our own infrastructure, but also helping the community. So they appreciate, at least most of them, what we are doing. But if you ask them what we should focus on, then it's mostly on the greening of ICT and in effect the data centers and green cloud solutions. So and I think this is interesting, and this is there's also a discrepancy in our community, and this is reflective in these questions on the funding arrangement we have, the innovatieregeling, that most of them think this is an effective way of stimulating sustainability in ICT, but on the other hand, most of them say, well, I'm not probably going to do a proposal next year, so there's sort of a passive attitude. So, and these are the first observations I'm making from this survey, that many people find this sustainability, this topic on green ICT, important, but it hardly comes natural to them. And whenever it comes natural to them, it's mostly on making ICT more efficient, so the greening of ICT part, and not so less the enabling part of ICT. And the other point for me, at least, is that even though we are working for quite some time with this community, I think we are focusing too much on the early adopters, and we should keep communicating on what we are doing here, even to the people not working on green ICT. If you look at the community, they after about a year or so, they started to being more active by themselves instead of being stimulated by us to do stuff. And we went to one of our universities, the University of Groningen, and because the ICT manager there, he's standing there proudly before his data center, He used the ICT scan we had done in 2010 and later on to improve his data center. And he managed to have annual savings of 150,000 euros, and they are aiming to increase these savings to more than 300,000 euros each year. And they do this from a business perspective, so it's not only to make the world a better place, but it's good for their pockets as well. And the things they are doing in their data center, they might not be very surprising, like virtualization and raising the temperature. He was actually saying to me that they used to have the temperature of like 18 degrees Celsius in their data center, and he said that, well, most equipment can handle now easily 35, 40 degrees Celsius, but the people started complaining. So they set it at 25% of 25 degrees Celsius just to keep the climate a little bit comfortable for them. And if you look at the community itself, it has grown to over 300 members, which we find pretty impressive because compared to other special interest groups we are running. And they start to have discussions among themselves instead of us starting a discussion and trying to get response from the community. They have organized themselves in work groups on green data centers, PC power management, sustainable ICT education. And they recently asked for a wiki, and we really want to stimulate such things. So what are the next steps we are taking? We want to keep facilitating people who want to be active participants, because we know from experience that when you start a special interest group, it takes at least a year to get this group active, and we see this coming back now, and we believe that if we keep putting our efforts in this, then the activity will increase. We want to involve students. This is something that I like to think about, because if you look at students, they don't really have any other motivation than to really improve things, and they are not held back by business as usual, or these things are not the way we are doing. This is not the way we are doing things here, and they just start. They have a goal and just start on something. For example, at the University of Amsterdam, a couple of students wanted a CO2 carbon neutral computer room, and they started to make a plan, try to get people involved, and actually with the support of the board of the university managed to pull this off. So it's a very nice example of how students can change things that maybe the people who are doing things there daily wouldn't think of in the first place. We think that if our institutions are transparent on the energy mix and their POE, we can change the collaboration and maybe share more experiences. So this is something we want to stimulate. We want to develop online business cases, because, for example, we did a study on power management, PC power management, and the study says basically that institutions could save tens of thousands of euros each year by installing the software. And after publishing this and giving this some attention, very few institutions said, okay, we are going to do this. And I think one of the problems is that this was a general business case we proposed, and maybe we should customize this business case so that people can fill in their own figures and see what it really means to them to install such software. And of course, we want to set up a wiki to share knowledge in the community. Finally, like I said, ICT, and this is something I believe itself will be a key component in a sustainable society. But as you see, for us, and maybe when you went to the previous talk from the industry, most sustainable solutions are actually just making ICT more efficient, and they are focused on the present instead of focusing on solutions for a low-carbon society. And I think that we have the infrastructure and the community and the collaboration power, if you will, to be able to think differently on ICT and really create solutions for the for a low carbon economy. So we could take the lead and set the example. And this is why SurfNet joined the Jeyang Green Team this year. And this is also why we are looking at this point and in creating a trainer task force on green ICT, because we want all NRENs involved to join our efforts, share our knowledge on the green ICT. And so I'm hoping that you would support this idea of creating a trading task force. Maybe you want to help, please drop us a note. You can find my email on the left side. And with this, I would like to thank you for your attention. And if you have any questions, I'm pleased to answer them.
Questions? Anyone? No? I think it's very interesting. Let me take it to there.
Yeah.
So I think it's a very interesting thing, and building a community like that is impressive. So what were the biggest kind of pitfalls? Like, if you just reiterate that part, like what was the thing that you think you did wrong, and like if somebody else wanted to make a community like that in their countries, that they needed to avoid?
Good question. I think we were trying to do everything at the same time. Mm-hmm. So the biggest pitfall is to lose focus, I think. Because when you look at the start of my slides, the green ICT can be very big, it can be everything. And if you focus on the couple of things that are most interesting for the community, then I think you can make a good start there.
Mm-hmm. Very cool. Any questions from the audience? Yes?
Hi, thanks. Robin Windsor with Cybera from Canada. You give the example of the data center that implemented a lot of recommendations and knocked the PUE down to 1.18, I think. What's the best practices you've seen? What's the best PUE, and where do you think those numbers are going?
Well, I haven't been there, but there's a recently opened data center in Utrecht that has a PUE of 1.07. So that's very impressive. But I don't know the exact details on how they achieved this. But I think maybe my colleague can. But but I can get back to you on that if you want.
We have time for more questions? Yes. Hold on a second.
I'm just wondering, how long will it take for the saved energy to compensate for the used energy by replacing working equipment?
Well, for service, I know that, well, the experts say that you could replace service within a year, 2 years, for the total cost of ownership to be more beneficial than keeping the old service. Yeah. Mm-hmm. So servers are, but it depends on the device, because if you look at the your mobile device, the ratio is exactly the other way around. Production is there much more important in the life cycle analysis, as you will, for mobile devices than compared to servers.
Mm-hmm. Maybe one more question. Yeah. So one more question. Can you comment on what's happening not outside of the NRENs and the academic communities? Do you know if industry and, I don't know, Holland and other places are doing similar type of actions, or do you have information about that?
Well, we have an industry community that's called Green IT Amsterdam, which is very active on greening the ICT, because Amsterdam is a big ICT hub. Mm-hmm. So they are sponsored by the government, and industry is really pushing there to make steps. Mm-hmm. What's also very nice is that the industry is was asking questions like how can we make software more sustainable, more energy efficient, and one of the applied universities in Amsterdam, they started a software energy footprint lab where they want to compare the energy efficiency of software. And this is one of the projects that we sponsored in our funding arrangement. Cool. So everything comes together there.
Right.
Yeah.
Very good. Final question from the audience? No. Let's thank the speaker.
Okay. Thank you.
So next up, we're going to get 2 short talks. The first one is by Eiríkur Hrafnsson, a local like me. And he's going to be talking about funny cats, which I really hope is going to make sense a little bit.
All right. The slide. Thanks, Emir.
Yeah.
Hello.
I should switch over to your presentation, huh?
Yeah.
Okay, let's do that. That's you.
Hello. My name is Eiríkur Hrafnsson. I'm the co-founder of Green Cloud, which is a public compute cloud that's a carbon neutral green replacement for Amazon. My short talk is about saving the world from funny cats, or actually how efficiency is not sustainability. Now, all of you today have heard about that ICT community or ICT infrastructure is causing around 2% of global greenhouse gas emissions. And if nothing changes, this number or figure could double in the next 8 years. Now, I believe the problem here is not just the matter of better efficiencies in IT, but simply that the industry is focusing too much on efficiency and too little on sustainability. So my conclusion before this lecture is that efficiency is not sustainability, and I'm going to go into a little bit why I think that's the case. So we just talked about, or the speakers before me just talked about PUE, which is power usage effectiveness, which basically measures the amount of energy wasted in data centers. Now, there's a lot of greenwashing going on in this industry, like, for example, Microsoft's data center in Chicago, where they talked about it being this really efficient data center with a PUE of 1.2. But the fact was that it's actually powered mainly by coal-produced electricity. So how can we get past this greenwashing and stop talking about PUE as the factor for being green and clean? Now, Green Cloud came out with a new metric 2 years ago, just a couple of months before the Green Grid announced carbon usage effectiveness, and we call it GPUE. Now, GPUE is simply a weight for PUE that takes into account the energy sources behind the data center. We also use the life cycle emissions of the energy production behind the data center. So, for example, coal produces roughly 1 kilogram of CO2 per usable kilowatt hour. Now, so you can see there's a short example there, which really helps to compare data center to data center. So data center 1.2 in PUE, that's using roughly 50% coal on the grid, is actually, has actually the GPUE of 1.8. And this is extremely useful for comparing data centers and their true greenness. But it's also an easy way to figure out what are the carbon emissions per usable kilowatt hour. So we put about a small table here that's based on numbers that Greenpeace put out in a report called How Dirty Is Your Data? And as you can see, the really, really green data centers, when compared with GPUE, really show their real faces. And on the rightmost side of that chart, you can see that, for example, the Chicago, Illinois data center is actually putting out roughly the same as a completely coal-fired power plant would put out for each kilowatt hour, or 1 kilogram. That's compared to Green Cloud's data centers here in Iceland, which roughly put out 0.02 kilograms per usable kilowatt hour. And that's in our data centers here that have a PUE of 1.1. And the reason for that is that we're using sustainable energy behind it, 30% geothermal and 70% hydro. So what's the deal with the funny cats? This was my idea for a talk today, which was sprung on me actually yesterday, so bear with me. The fact is that one Google search creates approximately 7 grams of CO2. And you can roughly estimate then 740 Google searches for funny cat pictures equals to as much as producing 1 hamburger. And this is called the cheeseburger footprint. Now, there are 500,000 million searches per month for cats or cat, including not so funny cats. Now, that equals to approximately 9,500 tons of CO2 every year, or around 1.8 million cheeseburgers. Now, the conclusion that I get from that is that funny cats are actually causing partly climate change, and we need to do something about that. So, in conclusion, if I approximate what I've been talking about, is actually that funny cats are not causing climate change. The fact is that more use of the internet and the rapid growth of cloud computing is putting more stress on us in building new data centers. And the data centers are the ones responsible for choosing the power source that they're buying. So the dirty energy is being used in the ICT community in all the wrong ways. So we have a great opportunity now to really start doing sustainable computing simply by choosing renewables in the data centers. And that's the key I want to leave you with. And efficiency, in my view, is not the same as sustainability. But we really can say that efficient sustainability is the same as truly green IT. And that's what we're actually doing with Green Cloud. And this was just a preview for my lecture on next Thursday at 9 a.m. And I hope to see all of you there. Thank you.
Questions for Eiríkur? Yes, please.
Hi, I've made the point a couple of times before that I'm from Canada. I'm from Alberta, Canada, where we have the oil sands. I'm wondering if you have the number for the multiplier to use for our particular energy source. I didn't see it on your chart. Maybe it was way off the top.
Yeah, well, if you take a look at the, let's see a table here, the multipliers for energy source. So what did you say? Do you know what the percentage is of nuclear, coal, whatever on the grid in that area?
No, but I'm interested to know what the footprint is for the oil sands from northern Alberta.
Yeah, okay, so oil or petroleum-based energy sources are around 700 to 800 grams per kilowatt hour. So that's a lot.
Yeah, perhaps even more if we mine them. Okay, thanks.
Probably.
Yeah.
More questions? We have lots of time, so please ask. So you'll have a second talk on Thursday. So I guess you can save your questions until then if you're interested.
Yeah, there will be a little bit more about cloud computing, but I'm sure some cats will come in that lecture as well.
Mm-hmm. Great. Okay.
All
So
right,
let's give the speaker a round of applause. So Andrew, you're up. Let me put your slides up here. Proceed. Mm-hmm. So our next speaker is Andrew Mackerel from HeNet. Is that how you pronounce it? HeNet. Okay. Yeah. So go ahead.
Okay. Good afternoon. I'm Andrew from HeNet, and I work with the network development group there. And one of the roles I have is working on a project called Manticore, as well as some other European projects. And I'm going to tell you a little bit about the Manticore project and one of the environmental test cases that we're actually going to have associated with the project. So what I'm quickly going to do is give an overview of the project, and I'm going to also talk about a liaison we have as an international collaboration with a group in Canada called Green Star Network. And to answer the gentleman at the back, Siberia were part of that consortium as well. And I'm going to talk a little bit quickly about how we set up a Euro GSN network. Then I'm going to talk about the GSN and Manticore use case, and because of a very short timeline, I'll just leave contact details and indicate we have a booth outside. Okay, Manticore. What is it? It's an open source solution that is going to allow, let's say, management and provisioning of IP network resources. So we are sort of bundling the part of the software development tool as open NAS. Is going to allow a flexible platform to be able to integrate other different network solutions with. So what it is, it's on-demand provision of network resources. It allows you to delegate access rights over these resources. It's a very lightweight abstraction model, and the idea is to decouple it from vendor-specific details. At the moment, the tool is implemented on one vendor, but we hope to have more vendors involved in the next few months. So the package itself has to be designed to be able to accommodate different network designs and different orientations of the network, and to be able to build and quickly change around networks. So there's modules that'll handle security, lifecycle, monitoring, deployment, and even with regard sort of energy resources and power monitoring. Tools that will actually carry out this power monitoring are just going to be treated as resources, and you'll be able to manipulate those resources. And the open NAS will develop individual unique drivers for each of these different utility features that you need. Back to this international collaboration. We're working with this group called Green Star Network in Canada, and what they're a consortium that initially was led by Canary, and it was a mix of universities, data centers, and renewable power generators, and other people involved in the power industry in Canada. And what they've looked at doing is trying to optimize the use of virtual applications by moving the application to data centers that were powered by renewable energy sources, and work out algorithms associated with that. So you can see that up here we have a map of Canada and a number of different locations. Some were solar powered, some were hydro powered, and I don't think they actually succeeded in having a location powered by wind there. In Ireland we did. What we did is we quickly integrated the network with some nodes that were powered by renewable energy sources in Europe. And initially it was one flat network, but we've since built a routed network. So this Green Star network, well, what's it doing? As I said, it's using the follow the sun, follow the wind module, and it's optimizing the distribution of virtual machines. So it's the applications according to the availability of these intermittently available green power sources. So you accept the fact that power isn't going to be available there all the time, and that you've got to sort of optimize where your data load is being run. So again, it's a layered type of architecture, and down at the very bottom device level you can actually see the PDUs, the UPSs, the smart meters. But as you step up each different layer, there's more and more complexity built in, and the real firmware intelligence is in the network manager, the cloud manager, and the facilities manager, which sort of align with sort of what the titles are. And the GSN controller is which makes the intelligent decisions. with Manticore, what we're going to do is we'd be aligning with an API from the network manager. So back to the network that has been established and built. So there's connectivity back to Europe now. There's a GSN hub that connects the nodes that are powered by renewable energy in Canada. And there's an equivalent European hub based in Dublin, and we have a number of nodes. There's one in I2CAT in Spain. There's one actually here in Reykjavik, and we have 2 nodes in Ireland, one powered by a solar panel PV array and one powered by a windmill. So these are just some photographs of the Irish location. You can see the windmill. It's at one of our clients called the Dundalk Institute of Technology. It's a very, very large windmill. It generates about 850 megawatts. At the other location, we have solar panel nodes, and this client, we negotiated with them and they installed another batch of solar panel nodes that we could actually use for experimental purposes. So you can see some of the kit that's actually installed in both locations. So while it's a research experiment, we've interested our clients in the findings. Like the EPA stands for the Environmental Protection Authority of Ireland, so they had a vested interest in sort of the work that we're doing. This is the local node here in Reykjavik. Again, most of these are just one Dell server with associated switches and some PDUs. So it's very, very basic, but the idea is that it has enough resources that we can move around a lot of virtual VM type tasks and applications. So what's our use case going to be about? Well, what we're trying to do is we're going to live migration of virtual machines between a number of these data centers, and that's based on when the renewable energy source is there. The idea is we're going to try to maximize and create a carbon neutral infrastructure, if possible, with the idea to try and reduce greenhouse gases. So to do this, we have to sort of build the network. What we're trying to do is we're trying to take away the concept of having a fixed network that connects all the different data centers and the equipment. So to set up the circuit, the connectivity initially, we were using the Xeon Plus data circuit connection service. But what we're trying to do is we're trying to switch and use services like bandwidth and demand, so that if we need to move a data load to a particular location, we create the circuit dynamically to move that data load. So Manticore and GSN have to interact, and well, what's Manticore going to do to this equation? Well, what we're going to do is we're going to have to configure the virtual router at each end and then make the connections to the virtual machine, build a connection between the nodes, allow for the data transfer that has to happen, that has been invoked to happen, and make that data transfer happen, and then disconnect the connectivity as well. So there's a lot of sort of complexity in each of the different operations, and if we're doing it dynamically and continuously, that we have to be able to do it consistently as well. So that's what Manticore is bringing to the table. And what we saw, it's just an illustrative test case in this environment. So this is just a quick representation of, as we see it, that we have multi-domains and we want to move resources from one location to another. And what we're doing is we're using physical routers, building virtual routers on those systems, and building dynamic connectivity between them, and enabling the protocols to make that happen. So, as I said, I was only expecting to have about a 5 to 7 minute window to make this talk. So what I've indicated is that we're available on booth 9, and we're all willing to talk and show, and we'll actually also run some demonstrations using Manticore and the bandwidth and demand system. It won't show you the interaction to the Green Star Network software yet because that isn't ready. But we're in the process of building that test case over the next few months. So I suppose, any questions?
Thank you. Any questions? Yes.
Yeah, so my question is, who are the customers for this type of live migration capabilities?
Yes.
And do you see a network popping up of really renewable energy data centers, actual big data centers, not just like a rack?
What again, the fourth thing is to show the proof of concept that the feature can be achieved and demonstrated that it is practical. With regard to renewable energy data centers, and a lot of that will be down to how they promote themselves, but also it's down to let's say their customer communities that they're serving. Things like the Giant Green Team, that if we are pushing aggressively to identify what we regard as a green data center, that what we're doing, we're starting to define new customer requirements for such a data center. And by aggressively pushing those type of demands, I think that's how you get to, let's say, sanitize or normalize what is a real green data center. Does that answer? Yeah.
Yeah, well, to me, it's quite clear what a green data center is. It's running on renewable energy. But
yes.
So my first question was a little bit maybe too cloudy, but I wanted to say that the use cases for such I think it's a great project, by the way. But the use case for the applications, like what types of applications do you see that could use something like this? Because obviously you're going to have to deal with latency.
Yes.
In some sense.
Yeah. The applications that were demonstrated were it was like video streaming. It was even interactive classes, and the experiments so far have shown that it is possible to transfer the virtual machine applications even without packet loss in such an environment. But again, that's with nailed up physical circuits. But we have to prove how well it'll work with on-demand type circuitry.
More questions? Okay, you have the mic, so you're next to them. Let's get the mic on, please.
It's working? Oh, yeah. Okay, my name is Sergi Fiola from I2CAT. Well, basically I'm working with Andrew in the project. And I would like to make a comment on the question about what is the application. Basically, the idea is that the existence of this is up to what point we can facilitate two things to the data center. One is, can we provide extra capabilities for them to calculate the CO2 credits for the energy that they're consuming? And not only this, but whenever they have to move virtual machines, are we able to identify where is the data center which is having best performance on energy, and what is the IP network that you have to create in order to be sure that we can migrate virtual machines over there? Because whenever you are using IP networks, it may have several hopes. So what is the best how we minimize the constraints that energy may have in order to impact as less as possible with the green IT parameters?
And I should also mention that our model would seem that we should be, let's say, running all our applications in Iceland because of the low greenhouse gas emissions, because you have such a renewable energy source. But we'll be building a model that it can handle lots of other different parameters and constraints. So it's nice to have something that has, let's say, that it's almost a model environment from which to work. So we can actually play off that. We're benchmarking against that type of location.
You had a question? Just hold on a second. Turn off maybe.
It was basically answered anyway, I think, because two things came to mind. First, you have a lot of network traffic, and I was wondering whether you take into account that the transport of the network isn't always green. I mean, these connections between the continents, they suck up a load of energy, and probably they're not powered by this windmill. The other thing is, I think this technology is very interesting for migrating workloads to greener places. If the applications you run are actually already suited to run in remote places. Just bring it closer. Oh.
Yeah. Yeah. Well, first of all, the sort of, let's say, the facility to that sort of uses the intelligence to decide where to run an application and to make that migration will be mostly part of the Green Star network software, and they're going into their second iteration of development now, so they hope to have another project funded for at least 2 to 3 years. So we're going to see enhancements to that open source software solution as well.
Yeah. Yeah, because basically the sun always shines in Iceland, for instance, if you consider follow the sun, because of the renewable energy here. Yeah.
More questions? I had a short question. So when you build a model, and it's easy to when you build a mathematical model, you pull in lots of different things, and you end up with this gigantic optimization problem. And you also end up with a bunch of parameters, and there's a big community around how you parameterize models, and then how you optimize it so that you can actually find what the values of those parameters should be. If you have all these things, you have all these constraints, like you want to take network bandwidth or network energy into account. You want to take the actual migration so that you respond to latency and all these things. When you're taking them into account, like how do you foresee that you can find suitable parameters that give you what you want from the model?
Again, it's an exercise in optimization, and you know, myself, I'm sort of, let's say, a network designer, sorry, a network implementer, not even a designer. Well, and I leave, let's say, some of the algorithm enhancement and sort of validity to some of the designers like Sergey's team. And also, too, what we're doing is that we have published papers in liaison with Green Star and other members in the community, and so we're always validating sort of approach against what's available both in the academic and even in sort of the industrial research communities.
Good. So, any final questions from anyone? No? Okay. So, thank you very much. And let's thank the speakers again.